So in the last recording of our water presentation, we're going to go over hydrogeology, which is the study of groundwater, which for many areas of the world, including in Canada, is an important source of water. Groundwater is stored in aquifers. Aquifers can be made out of a variety of materials. They can be made out of certain rocks that are naturally good at storing water. Think of limestone as a good example. Sandstone as well could be in an aquifer. You can also have rocks that are on the surface not great at storing water, but maybe they've been fractured by tectonic processes, so they can store water. And the third, and this is quite common in many parts of Canada, is sediments, especially glacial, coarser sediments. Think your tills made of sand and gravel are quite good at storing water. For an aquifer to be a good aquifer, it must be both porous and permeable. Porosity describes the amount of void space, amount of air in the rock relative to the amount of rock itself. And permeability describes the ability of water to flow between these void spaces or pores. Two main types of aquifers, unconfined and confined. Unconfined aquifers, they're sort of right below the surface. You can get water recharge through here, so they're well exposed to the atmosphere, and they're sort of at atmospheric pressure. Confined aquifers, they're topped not by a layer that connects to the surface, but by a confining layer that is not porous or permeable, does not let water through on its own. They do have a small recharge area, but overall they're topped by this confining layer. As a result of this, they can often be under a lot of pressure, so when you drill a well into them, often you get the water spraying out like this, forming an artesian well. If you've seen like oil spraying up when you reach a new oil deposit, it's the same concept, but with water. And you'll see these signs on the highway, at least in Ontario, for drinking water protection zones. These are around recharge areas for aquifers, because obviously you want the water going into your aquifer to be relatively fresh. This is in a protection zone. You have to be careful about the amount of salt you put down on roads and different agricultural things you use, so it doesn't contaminate your water supply. Aquifers don't just store water, they store oil and gas as well. Oil and gas flows through these aquifers until it is trapped in an oil trap, which are often the areas where people go and extract oil and gas. Different types of geological oil traps. In workshop 2, we discussed the anticline fold, forming the anticline trap. They're separated by density, so natural gas is the least dense, then you get oil or petroleum, and often below that you'll get water, because water is more dense than petroleum. You also can get fault traps, salt dome traps, and even just stratigraphic traps where the layers of rock are in a particular arrangement. Closely associated with groundwater is karst topography. Limestone is one of those rocks that are naturally good aquifers because limestone is soluble in rainwater. So you often get water carving out weaknesses along the joints. So you get things like caves, as well as you get sinkholes or dolines, and also disappearing streams, or the stream goes underground for a bit. And here's a good picture of karst topography where you see dissolution of limestone along the joints in the rock. Groundwater is of course used as a source of water for drinking and irrigation. However, you have to be careful about overusing it. A couple problems you can run into are subsidence and saltwater intrusion. Subsidence is when you pull out too much groundwater, and groundwater takes up space underground, so if you pull it up and it's just air under there, then the ground may sink to fill the space. This has two problems. One, you get your ground sinking quite a bit. This is California's Central Valley, and you've seen the ground here. You can see the ground has sunk 9 meters in this time, and I think it's sunk even more in some places to today, because this is from 1977 due to overdrawing of groundwater. So that can create problems on the surface, but also now that there's no longer that space underground, it prevents the aquifer from recharging to the extent it used to, which means there's less water available down there. The second is saltwater intrusion. If you have an aquifer like this, where you have fresh water, it keeps the salt water sort of out. But if you draw out the fresh water, then the salt water will creep in, and then soon enough you'll be pulling salt water out of your well instead of fresh water, which of course is useless for either drinking or irrigation. To end off on a note that aquifers can occur quite deep under the earth as well, and the deeper aquifers that are sort of cut off from the surface, the water may not have been in contact with the surface for millions or even billions of years. This is billion-year-old water from the Kidd Creek mine in Timmins, and a professor at U of T, Dr. Barbara Sherwood Lawler, has done a study on this water, and I highly recommend you read the CBC article here about her work with the world's oldest water. So that is it for our water-related recordings. Thank you so much for watching.